My name is Chong Yong Jin. My metric number is B122310419. This project is part of the BERE2364 Control Principle course. It gives students a chance to apply what they have learned in class by designing and testing a control system using MATLAB. In this assignment, students will model systems in different ways, design a controller to meet specific goals like reducing overshoot, and check if the system is stable. By doing this project, students will get better at using simulation tools and learn more about how control systems work in real-world situations. This project has several main goals to help students apply what they have learned and build a working control system. The objectives are to design and model a control system using MATLAB, to represent the system using both frequency domain and state space methods, to analyze the system's response, including step response, poles, and zeros, to design a controller that meets a specific overshoot requirement, to evaluate the system's stability using the Rod-Hurwitz method, to apply theoretical knowledge in a practical project, and to improve skills in simulation, analysis, and control system design. The background studies in this project is control systems are used in many machines and devices to make sure that they work properly and within set limits. They help improve how systems respond, keep things balanced, and make the systems work more efficiently. In this course, we learn how to model systems, design controllers, and check if the closed-loop system is stable. There are two main ways to model a system, which using transfer function and state space methods. This helps us to predict how a system will behave when given certain inputs. Once the system is modeled, we can design a controller to control things like overshoot and how fast the system responds. And also stability is just important. If a system is not stable, it might behave unpredictably or even fail. The Rod-Hurwitz method helps us to check stability without doing a lot of complicated math. It gives us a quick way to see if the system will behave well under different conditions. This project gives us a chance to use what we learned in class and apply it to real situations. By using MATLAB for simulation, we could see how control systems work in real life.
Assalamualaikum and very good morning. So my name is Abdul Kadir. So today I'm gonna present for my part, which is part A, that I have simulate and do the coding. So part A is system modeling of our control system projects. In this section, we focus on representing the system both in frequency domain and state space form, and then simulating its behavior using MATLAB. So this is my MATLAB and the coding. Okay, so we started by deriving the transfer function of the system using Laplace transform based on Laplace transform. So this is my calculation for the transfer function. Okay, so this function describes how the output respond in the frequency domain. So this is all I have put in the report. So next we go to the simulate the unit step response of this transfer function. The plot shows how the system reacts over time when a step input is applied. So the key of this observation is the system has a smooth rise. So how to check it has smooth rise? So this is my coding for part A. Okay, this is my coding for part A, and then we're gonna check the result. So this one, we have a smooth rise. Okay, and then no oscillation, indicating a stable record second order system. So this is for the part A. And then we go for the next one, which is poles and zeros. Poles and zeros means analyze the poles and zeros of the system using MATLAB. So poles were located at value that made the denominator 0, and zeros were found solving the numerator. So we're gonna use this coding, okay, and then we're gonna go to this one as our figures. This is our result. So the poles were located at values that the denominator is 0, and then the zeros were found by solving the numerator. So you can see how the graph goes. Okay, so next one we're gonna go for part 3. Part 3 is part A, and then the pole 0 confirm the system is stable since all poles lie in the left half of the S-plane. Okay, so we're gonna go for the state space representation. So this one. Okay, so this is my calculation for this one, and then we're gonna go for the unit step response of the system. So using the state space model, we again simulated the unit step response in MATLAB. The result matches the transfer function response, confirming the accuracy of both models. So that is our next one, this one. So this one I'm gonna run, and then it gonna perform the output. So as we can see, the output is okay. I'm gonna run. Okay, this one. So the pole zero diagram of G. This is our transfer function. Okay, so the observation and the comparison. So both of transfer function easy to get poles and zeros, and then for the transfer function also best for single input and single output analysis. So for the state space, useful for analyzing internal behavior and MIMO system, and then essential for advanced controller design. Both model produce consistent result, made estimation verify the theoretical calculation. So this one is for our next part, which is unit state response also, and then I'm gonna run this one. Okay, this one is for unit state response from state space method part A. Okay, so I'm gonna run this one, and then we can open this. Okay, so you can unit state response state method for part A. So this one. Okay, so and then next we have a conclusion for my part A. So to conclude, I'm successfully modeled the system in both frequency and state space domain, but my math estimation matched the theoretical expectation also. This step is critical in understanding the system dynamic before controller design in part B. So that's all from me. So thank you so much.
My name is Muhammad Salim Azhar. My matric card number B0822101181. I can explain about part B for controller design. For introduction, controller design involves creating algorithm to ensure stable and efficient system performance. Used in a field like robotics and automation, it includes modeling, set the controller, and testing. For the design, and this is our overshoot is 16%. Our calculation for zeta, we get 0.580. For phase margin, we get 57.84 degree, and we minus 180 plus 57.84 and equal to 122.16 degree. So our calculation transfer function, this is simulation MATLAB for coding, and the hour graph. So we get a phase 102 and the frequency 0.651, and then the magnitude we get a 8.66. This is our gain margin calculation. For conclusion, the controller design achieves system stability, optimal performance, and robustness. Using the PID and state space technique, the system performance are reliability, discrete sensor, and computational elimination.
Assalamualaikum, my name is Yusri Zolakini and I will explain for part C, stability analysis. For part C, this section will explain the importance of stability in control system. The purpose of stability analysis is to ensure that the system provides a control response when receiving input. So first, we get a transfer function from part B, and then calculate the TS to find new transfer function using closed loop formula. From the calculation, we get a new transfer function. And lastly, we use a Rod-Hurwitz method to check whether the system stable or not. And from our calculation, there are no sign change and no entire row of 0. So all the poles are on the left side of the S-plane. That means the system is stable. That's all from me. Thank you.
Okay, so to sum up, my conclusion is, in this project we work on designing and analyzing a control system using MATLAB following 3 major parts. So for part A, system modeling, we derived the transfer function of the system and converted it to state space. Both models were analyzed using MATLAB simulation. We observed the step response, poles, and zeros to understand the system dynamic behavior. So for part B, controller design, we designed a gain compensator to meet the required overshoot range, 5 to 25%. So for our range is 16%, so MATLAB was used to tune the system and plot the block diagram. So the design will help improve the system response while maintaining stability. So part C, we applied the Rod-Hurwitz method to determine the system stability. All elements in the first column on the row of array were positive, confirming the system is stable. We also confirm this through MATLAB state response and pole position. So to sum up our final conclusion, to conclude, this assignment gave us hands-on experience in designing and analyzing a control system from scratch. So this one, we just using our MATLAB. So we successfully model a system using both transfer function and state space, design and controller to improve system performance, analyze system stability using mathematical and simulation tool. Through this, we improve our understanding of control theory, develop MATLAB simulation skills, and show how control concepts are applied in real world engineering. So this project prepares us for future work in automation, robotic, and system engineering. So thank you so much, Madam Dr. Syaratu. So that's all for our assignment. Thank you.